So hello guys, welcome to Dev Domain. In today's video we are going to see how a binary algorithm or binary search algorithm works. Okay, so let's start. A binary search algorithm is a highly efficient method for finding a specific value within a sorted array. Okay, so in previous video we have seen the linear search. There also we find a element in the array. Okay, so here in binary search also we have to find a element or a specific value in the array, but binary search is efficient than the linear search. So how it is efficient, let's see further. It works by repeatedly dividing the search interval in half, eliminating portions of the array that cannot be contain the target value. Okay, so we divide an array in two parts. Okay, in first part and in second part. Okay, if the possibility of value is present in the second half, then we eliminate the first half and search in second half only. Okay, so next point will be, this approach significantly reduce the search time compared to the linear search. Okay, so that's it is faster than the linear search. Okay, in linear search we have to go to each and every point and see the element is matching with the targeted or the key value. Okay, the key concepts will be sorted array. Okay, the array must be sorted in ascending or descending order for binary search to work correctly. Okay, so the array must be sorted, then only the results will get correctly. Okay, now second point will be divide and conquer method. The algorithm divides the array into two values on the half that potentially contains the targeted value. So as we have discussed the in above points. Now third point will be logarithmic time complexity. Okay, so binary search has a time complexity of big of log n. Okay, making it much faster than the linear search. That's obviously uh, big of n is less than the big of log n. Okay, if we have to write the algorithm for finding a solution, so we write in binary search. Okay, so we get the results faster. So let's take an example. I have created a array here. Okay, now this element, take it as start, the last element take it as end, and this middle value take it as mid. Okay, so the logic will be, while we have to create a loop, and we have to write the condition in that start should less than the end. Okay, until the loop ends, and then in that we have to create start is equal to 0. Okay, and then we have to create end is equal to array of length -1. Okay, and then we have to create, and mid basically is equal to uh, start plus end divided by 2. Okay, um, let's say 10. Okay, so the key is 10, means the targeted value. Okay, now now we have to write three conditions. Okay, so if mid is equal to array of mid. Okay, so if key is equal to array of mid. Okay, by mistakenly I have written mid here. If key is equal to array of mid, means if the middle value is equal to key, then we have to return mid. Okay, means it's index value. Okay, now if key's value is less than the array of mid. Okay, then the condition will be we have to update the end value here. Okay, so end is equal to uh, mid minus 1. Okay, and third condition will be if key is greater than array of mid. Okay, then we have to update the start value. So start value will be start is equal to mid plus 1. Okay, the example. Okay, so I have created start is equal to 0 here, and array, and the end value will be array of length minus 1, means this. Okay, now the mid is equal to start plus end divided by 2, means this value. Okay, now I'm checking the condition here. Okay, if key is equal to array of mid, means if this key is equal to mid, the condition will be false. Okay, so the next we have to check here the next condition. Okay, if key is greater than array of mid. Okay, if key value is 10, if key is greater than array of mid, no, the condition will be false. Okay, now here we have to check this condition. If key is greater than array of mid, means key is greater than array of mid means 8. Yes, this value is true. Then the start value gets updated, as we have seen here. The start value gets updated by mid plus 1. Okay, start value to mid plus 1, the start will be the next value, means 10 will be the next value, and end value remains same as we seen in the above array, and mid value gets updated. Mid value is what is the mid value? Start plus end divided by 2, means the middle value, means 10 12. Again it will compare with the key. Okay, now it will check if key is equal to mid array of mid? No, here 10 is not equal to 12. Okay, now it will check the condition. If key is less than array of mid, okay, if key is less than array of mid, yes, the condition will be true, and end value gets updated. Okay, end value gets updated by mid minus 1. Okay, now we will get only 10 here. Okay, now start will be this, end will be this only, and mid value will be this only. Okay, and again we check the condition. If key is equal to array of mid, yes, the key is equal to array of mid, and from this we get the our targeted value. Okay, okay, so this way the algorithm works. So let's see in our practical session how we can write the code for it. Okay, let's start with our demonstration. I have created a class called demo, and in that I have created a main function. Now I'm creating an array. Array is equal to, we created an array. Now I'm creating a function. So public int, okay, and search. Okay, now in that I'm passing the array. Okay, and the key will be here, key will be 10. Okay, now let's create an variables. Start is equal to 0 and end is equal to array dot length minus 1. Now let's create a while loop, and in that give the condition start is less than or equal to end. Okay, and in that I'm creating a mid variable. The mid variable will be start plus end divided by 2. Okay, and I'm giving the conditions here. Okay, so if key uh, is equal to array of mid, okay, then the return, we have to return the key mid. Okay, then we have to obviously return the mid. Then if the key is greater than the array of mid, okay, so the key must be present in first part. Okay, so we have to update end. Okay, end will be mid minus 1. Okay, now third condition will be if key is greater than array of mid. Now key must be present in second part. So we have to update start. Start is equal to mid plus 1. Okay, I have to return the minus 1. Okay, if key is not found here, then we have to simply return the minus. Okay, now from main method we have to call the uh, function. So let's call demo. D1 is equal to new demo, and in now D1 dot uh, what is the function name is search. Okay, now and in that we have to pass this. Okay, now let's run the code and see output. Okay, so we get the output as 4. So okay, starts with 0, 0, 1, 2, 3, and 4. The key is present on 4 index, so we get the index as 4. Okay, so this way the binary search algorithm works. So thank you for watching this video.